All right, let's dive into a seriously powerful tool for researchers and analysts out there. Partial least square structural equation modeling. You know, a mouthful, so we'll just call it PLS-SEM. It's gotten this reputation as a silver bullet because it can solve some really tricky problems. But is that hype, or is it the real deal? We're going to find out.
So first off, let me ask you something. How do you actually measure an idea? I mean, how do you put a number on something like brand loyalty or job satisfaction? You can't see it, you can't touch it. But these things are absolutely crucial for understanding why people do what they do. And that is the exact problem that methods like SEM are built to tackle.
Okay, here's our game plan to get to the bottom of this. We'll start with the basics. What even is SEM? Then we'll look at its two main flavors, because they have very different goals. After that, we'll peek under the hood of PLS-SEM itself. Then comes the practical stuff. When should you actually use it? And finally, we'll deliver the verdict on that whole silver bullet claim.
So let's kick things off with Section 1. What in the world is structural equation modeling? Well, you can think of it as a tool for mapping out all the unseen connections and forces that are at play behind the scenes.
Basically, SEM is a statistical technique that helps us test and understand the relationships between the stuff we can measure, like answers on a survey, and the abstract concepts those answers represent. We call those concepts latent constructs. So it's like a bridge connecting our visible data to the invisible ideas that we really want to understand.
Now here's a key thing to get. SEM isn't just one single method. It's more like a toolkit, and it has different tools for different jobs. There are two main approaches, and knowing which one to grab really depends on the kind of mystery you're trying to solve.
And this brings us to a really fundamental split. On one side, we have what's called covariance-based SEM, or CB-SEM. Think of this as the established veteran. Its main job is theory confirmation. It asks, does the data I've collected actually fit this well-known theory? It's all about validation. But then you have PLS-SEM, the versatile challenger. Its goal is totally different. It's about prediction and exploration. It asks, what are the most important things driving this outcome? It's for developing theories, not just testing them.
All right, so how does this explorer, PLS-SEM, actually work its magic? Let's pop the hood and take a look. And don't worry, we're going to keep the math out of it and just focus on the core ideas that make it so darn useful.
So first, we have to really get our heads around this idea of a latent construct. Let's take an example. Imagine you want to measure health. Well, you can't just measure health directly, right? Instead, what you do is you measure a bunch of observable things that reflect health. Things like blood pressure, heart rate, how much someone exercises. In this case, health is the unobservable latent construct, and all those measurements are its indicators.
And this is how we visualize it all with what's called a path model. It's basically our map. You see the ovals? Those are our latent constructs, the big abstract ideas. And the boxes? Those are the indicators, the actual data we collect from the real world. This map has two parts: the outer model, which links our data points to the concepts, and the inner model, which shows how we think those abstract concepts influence each other.
The PLS-SEM algorithm is pretty clever. It works in a two-stage process. First, it looks at all our indicator data in the boxes and uses that to figure out the best possible scores for the latent constructs, the ovals. Once it has a good handle on those, it moves to stage 2, where it figures out the strength of the relationships, the arrows, between them. This tells us which concepts are powerful predictors of other concepts.
Okay, that's the how. Now for probably the most important question. When should you actually use PLS-SEM? Like we said, it's all about picking the right tool for the right job.
This little table gives us some fantastic rules of thumb. You want to go with PLS-SEM when your main goal is prediction or finding the key drivers of something. It also really shines when your model gets super complex, with tons of concepts and questions. And here's the big one. It's incredibly flexible. It works well even if you have a pretty small sample size, or if your data isn't perfectly normal. It doesn't fit that nice, clean bell curve that a lot of other methods demand.
And that brings us right back to where we started. With all this power and flexibility, we have to ask, is PLS-SEM truly the silver bullet that everyone says it is?
Let's just tackle that question head on. We've seen that it's great for prediction and it's awesome at handling messy, real-world data that other methods would struggle with. So, what's the final call?
Well, like most powerful tools, it's a bit nuanced. The pros are huge, no doubt. It's amazing for prediction, for complexity, and for tricky data. But it's not perfect. It does have one big con. Its statistical estimates are inherently a little bit biased, and because of that, it's not the right tool if your only goal is to confirm an existing theory with the absolute highest precision. So yeah, it's a powerful tool, but it's not a magic wand for every situation.
But in the end, the authors of the paper we're looking at wrap it up with this really powerful thought. They say that PLS-SEM can indeed be a silver bullet, but only when it's used for the right reasons. For researchers who are focused on prediction, on exploring new ideas, and on dealing with complex, messy reality, PLS-SEM isn't just a good tool. It might just be an essential one for finding answers that would otherwise stay hidden.